let's analyze this circular motion a little bit. Let's say we're given a particle, mass m, charge q, in a uniform b. So again, let's put it in a uniform b that looks like this. They're fun to draw. And we already agreed that the charge will go in a circle because it'll always feel a force at right angles to its velocity. So it's going to go around like that. Going around this way, feeling a force, always seeking the center. So the first thing you could ask about this motion is, what is the radius? Well, you get it by solving kinematics the same way you solve them for 1D motion, is you apply Newton's law. Sum of the forces equals ma. We can apply that here. Now we're not doing it quite as generally as a 1D problem in 3 dimensions. We're assuming we have circular motion. Since we're assuming circular motion, we know that what goes here is the centripetal acceleration. If you want to be general, you could have both translational and centripetal acceleration. But here, we're confined to a circle, so it's only that. So we can solve it and say, well, what is the force? Here we're just going to do magnitudes. We're not thinking about directions. The direction is constantly changing. The magnitude of the force is Q VB. All right, we were given Q, we were given B. We know it's moving with some V. And that's going to equal to M. We were given M, and the centripetal acceleration is V squared over R, which you may remember from mechanics. There's R, the radius of the circle. So we can start canceling things and see that and solve for R, and you get that R, the radius of the circle, is mv over qb. So that's worth memorizing, especially when you're taking a class in magnetism. The radius of the circle of a charged particle in a uniform field is mv over qb. It even rhymes, mv over qb. It kind of makes sense too if you look at it. This is the momentum of the particle, right? Mass times velocity. It kind of makes sense. The more momentum it has, the harder it is for the field to get it to turn. Right? So the bigger the momentum, the bigger the radius. That's why it's in the top. And QB are related to the force. The bigger Q, the bigger the force. The bigger B, the bigger the force. The bigger the force, the bigger influence it has on the motion. So it's going to push it even harder. So therefore, the bigger Q and B, the smaller the radius. So that one makes sense. The radius is mv over qb.